So in this problem, we're asked to find all solutions to the equation 6x to the fourth plus 5x cubed minus 17x squared minus 6x equals 0. So it's always good to be on the lookout for common factors. That'll help you out here if you notice that each term here includes the factor x. So we could start by factoring out x to the first power here. And we're left with 6x cubed plus 5x squared, 17x. Everything comes down a power. At this point, as soon as you pull out a factor here, we should go ahead and set aside this factor, in this case x, set that equal to 0, and okay, there's one solution. So now we can focus on solving this equation. So at least now notice it's 1 degree lower. That's just a tiny bit better than what we started with. And we're looking for all zeros of this third degree polynomial now. Okay, so this might be where we get a little bit hung up because it won't factor by grouping. If you try to group the first two terms and group the second two terms, you're not going to find a common factor here. So what you can do to get unstuck when you're finding zeros of polynomials is to use the Rational Zeros Theorem. The Rational Zeros Theorem allows us to come up with a list of potential zeros by taking factors of the constant term. So in this case, deciding what color to use. So in this case, factors of constant term -6 over the factors of the leading coefficient, which is 6. Okay, so that'll generate this list. Factors of -6. So we've got plus or minus 1, plus or minus 2, 3, 4 and 5 are not factors of 6, but 6 is. And then factors of 6 in the denominator, well, okay, it's going to be the exact same list. Because we're just listing factors of 6 again. So that generates, I'm going to write our official list of potential zeros here at the bottom, and then I'll have to erase what's on top. So I like to go with one denominator at a time. So say the denominator is 1. So then part of our list of potential zeros here would be 1 over 1, 2 over 1, 3 over 1. So that's going to give us 1, 2, I'm just going to leave the plus or minus in front of the whole thing. 3, 6, just know that that plus or minus applies to everything in this list. All right, so that's dividing by 1. Now suppose we divide by 2. So that'll give us 1/2. 2 over 2 is 1. 3 over 2, that's new. I can add that to the list. And 6 over 2 is 3, which is already on the list. So we don't need to write that again. Okay, so we've dealt with denominator 1 and denominator 2. What if the denominator is 3? Then we have 1 over 3, 2 over 3, that's new, that goes on the list. 3 over 3 is 1, already listed. 6 over 3 is 2. Okay, so that's denominator 3. Denominator 6 will give us 1 over 6, which is new, so we add it. 2 over 6, well, that's 1/3, already on the list. 3 over 6 is 1/2, already on the list. And 6 over 6 is 1, already on the list. Okay, so here's our potential zeros, thanks to the Rational Zeros Theorem. Let me erase this. So what we would do now, maybe to save space, I'm going to write this where we factored out x up here. Okay. What we should do now is plug in these values until we find one that works, which is kind of sad news to hear because that's going to take a while, but let's see what we can do. actually, to keep this video from getting too long, so if you want, try it out, plug in 1, you're not going to get 0. You'll get 6 plus 5, what's that, 11, minus 17 is negative 6, and then minus 6 again, negative 12. We're not getting 0. If you plug in negative 1, we'll get negative 6 here, positive 5 here, so that's negative 1 so far, minus 16 or 17 times negative 1, so that's plus 17 minus 6. It's not going to give you 0. Okay, let's try negative 2. Now, instead of plugging negative 2 straight into this polynomial, another way to figure out what you get if you plug negative 2 into this polynomial is to use something called the remainder theorem, which says if we do synthetic division with negative 2 here, and I'm going to put the coefficients of this polynomial here, then whatever we get for the remainder here is going to be equal to f of negative 2, where I'm calling this function right here f of x. That's what the remainder theorem says. It's the same thing you would get if you plug negative 2 straight in. So let's see, if you bring the 6 down, then this is negative 12. So negative 7 here, so this will be positive 14. So negative 3 here, and then positive 6 and 0. So I'm cheating a little bit, hopping to negative 2, but it turns out that negative 2 does divide out cleanly here with the synthetic division. So what that tells us is that this polynomial here, which I guess I'll rewrite, plus 5x squared minus 17x minus 6 is equal to x minus negative 2. So like if negative 2 is the value we put here, then we're thinking about the factor x minus negative 2, which is x plus 2. That factors out, we know that because of this remainder of 0, and the remaining polynomial will be given by these coefficients. So 6x squared minus 7x minus 3. So now we had x factored out earlier. We said x equals 0 is the solution. If you just kind of go down the list here, eventually you'll try plugging in negative 2 and find out that that works. So then you get x plus 2 factored out. Okay, so we've got a solution x equals negative 2 now from this factor, if you set that factor equal to 0. Now to find the remaining zeros, we would set this quadratic factor here equal to 0. And I'm going to get rid of the top of the board again. Need a bigger board. This is okay. So now we're down to this quadratic factor here. And actually, let me keep track of the factorization. So we know this is x times x plus 2 times this. That's where we are now. We want to set this factor equal to 0. You could solve that, since it's a quadratic expression, you could solve it either with the quadratic formula or by factoring. I'm going to talk through the factoring. So say we want to factor this. I'm going to go through what's called the AAC method. So we want to find two numbers whose sum, well, sorry, let's do product first, whose product is a times c, which in this case is 6 times negative 3, so negative 18, and whose sum is b, which is the middle term, so in this case negative 7. So two numbers that multiply to give you negative 18 and add up to negative 7. How about 9 and 2? I want it to multiply to give me negative 18, so one of those needs to be negative. If I want them to add up to negative 7, then the 9 should be negative and the 2 is positive. So with the AC method, what you do then is take this middle term, negative 7x, and use those two values. So instead of writing minus 7x, write minus 9x plus 2x, which is equal to negative 7x. We're just kind of expanding it out. Keep the first term and the last term the way they were, and then factor by grouping. So we look at, okay, what can I factor out of the first two terms? That would be 3x. And you're left with 2x minus 3. Okay, what can I factor out of the second two terms? Well, nothing. There is no common factor, so we can just put a 1 outside. And then this is when you know that factoring by grouping is going to work, when these factors match. So now this whole thing, this quadratic factor here, can be factored as 3x plus 1, 2x minus 3. And then I'm going to copy down these other factors. So then we still have the x and the x plus 2 if we're talking about factoring the whole thing. Which, by the way, on some of your homework problems, you'll see the instruction express the polynomial as a product of linear factors. So if you're asked to express as a product of linear factors, you're being asked to get to this step right here. And this would be your answer. X times x plus 2 times 3x plus 1 times 2x minus 3. I'll put that in writing. So when you see that in your homework, you know what's expected. So the instruction with these will be express as a product of linear factors. Then this would be your answer. Now, the way I gave the instructions in this example is find all solutions to the equation when it was set equal to 0. So for finding all solutions, you would set each factor equal to 0. And you would get x equals 0, like we talked about, x equals negative 2 here. If you set 3x plus 1 equal to 0, you'll end up with x equals negative 1/3, which notice that was on the list. We would have got there eventually. And set this factor equal to 0, you'll end up with x equals 3/2, which again was on the list. We would have got there eventually.